Okay, so this pretty much finishes up the chapter. I want to do a second video for everybody on colloids. We know how to spell colloids?
C-O-L-L-O-I-D-S.
Okay, this is a different class. The other class was very zombie-like. It was difficult, it was painful. Yes, they're a very quiet class. They're very nice people, but they're very quiet. Okay. What do we have? What's the story with colloids? Anybody want to start us off? Yosef, what do you got?
It's one of three primary types of mixture.
It's one of three primary types of mixtures. Is that what you said?
Yes.
One of three types of mixtures. Okay. So what are they then?
A solution and mix.
Solution, which is homogeneous, isn't it?
Yes.
A solution is homogeneous, right? Yes. And the particle size is going to be less than 1 nanometer, right?
Yes.
And then what's the second one?
Collision.
What is it? Suspension?
Yes.
Okay, and that's heterogeneous, right?
Yes.
And that's going to be greater than
1,000 nanometers.
greater than
1,000.
a micrometer or 1,000 nanometers, right? Is that what you were saying?
Yes.
Right. And then the third type is what we're studying right now, isn't it? It's a colloid.
Between
1 and
1 nanometer.
So it's between 1 micrometer and 1 nanometer. And it's heterogeneous, right? I think I misspelled that. Long word to spell, isn't it? Probably the longest word I use in the course of a day. You don't often use 13-letter words in the course of a day, do you? Yes. Okay.
A solution and a colloid are heterogeneous.
Or what?
A suspension and a colloid are heterogeneous.
That's right. Heterogeneous and heterogeneous. Right? Right? What else about... So you started off... Good. You started off by saying that a colloid is sort of between a solution and a suspension, isn't it? I didn't write it between. I purposely did that so we could leave off with what we're starting with. But this is less than a nanometer. This is greater than a micrometer. And a colloid is between a nanometer and a micrometer. Alec.
What's the mean heterogeneous?
Heterogeneous means not a complete combination. You could say heterogeneous in terms of purity. The material was heterogeneous, meaning it was a substance. It was either a specific compound or a specific element. So you can use heterogeneous to talk about the purity of something. We're all one political party in here. Okay. We're all from one country, or you're all boys or all girls. Okay. Or you could talk about it as a combination. Okay. I have 12 boys and 12 girls, and everyone is evenly spread out. Okay? Yes? So you can talk about homogeneous and heterogeneous in terms of its purity or in terms of its combination. If it's completely, thoroughly, absolutely, positively, 100% mixed, then that's homogeneous. Now you're going to say to yourself, well, why wouldn't a colloid be homogeneous if it's really completely thoroughly mixed? That's the literature, that's what they say. So in terms of being thoroughly mixed, it really doesn't, the definition falls apart, doesn't it? A little bit, yeah. But they say that, whatever. Anyway, what else about a colloid? Yes, Fabi?
They can be solid, liquid, or gas.
They can be solid, liquid, or gas. I like that. They can be solid, liquid, or gas. Do you have an example of anything like that, Gabby?
Yeah.
I mean, Fabiana?
Fog.
Fog. I like that. Fog is an example of what? What's fog an example of? Well, let's hold off on naming specific examples right now, because that's a good one, though. Fog is a really good one. Yes?
It exhibits the Tyndall effect.
The Tyndall effect. What's the Tyndall effect?
So you can see light as it passes through.
Yeah. If I pass light through a solution, it doesn't refract or scatter, it doesn't diffract or refract at all over and above what it would be doing if it were going through a glass vessel with pure water in. Right? That's a solution. But because the size of the particle is larger than a nanometer, you're going to get this scattering of the light. So you can actually test to see, is this clear liquid pure water? Is it a solution? Or is it a colloid? Well, I can determine whether or not it's a colloid. I can narrow it down. If I shine a light through it and it scatters, it's a colloid. If it doesn't scatter, it's either water or a solution. Correct? So the scattering of light. Great picture in your book on the Tyndall effect. Yes? What else? Tyndall effect. I like that. Yes, Yusuf.
Rubbing glass.
What is it?
Rubbing glass.
I'm sorry, I don't understand. What did he say?
Rubbing glass.
Rubbing glass?
No, rubbing glass. Rubbing glass.
Rubbing
Ruby
glass.
Ruby glass?
Ruby glass.
Okay, what's ruby glass? What's that mean?
Red glass.
Yeah, it's red.
Yeah. Red glass. Go ahead. A ruby color.
Yeah.
Why don't you do a little bit more research on that and we'll get back to you. How's that? We'll have somebody help you with that. Dylan? Not very busy back there, are you? Yeah, I can tell. So, yeah, you're right. I can see that. So why don't you work with your partner, Yusuf, and look up some ruby red glass and how that's a colloid, okay? So you and Yusuf can work on that a little bit, okay? Yeah? Yes, Fabiana.
Whipped cream.
Whipped cream is an excellent example of a colloid. You didn't give me a very, very important definition, though, of a colloid. Something that makes a colloid different from a suspension, for instance. Go ahead, Ishmael.
The particles are smaller than.
Yeah.
The particles are smaller.
They don't settle.
They don't settle.
They don't settle. They're stable.
They're stable. A colloid is stable. It doesn't settle. It's stable.
Sir, is smoke a colloid?
Is smoke a colloid?
Dust in the air is.
Dust in the air is. I guess if the smoke particles are small enough. I mean, smoke, you can actually see smoke settle, can't you? So it depends on what is in the smoke. Right? Well, we live in Abu Dhabi. This is Abu Dhabi, right? And we live in the middle of a desert, essentially. 50 years ago, this was a desert. Yes, they built in the desert. In May, oftentimes, when I read about Abu Dhabi, the weather in Abu Dhabi, they were very specific about one thing. Dust in the air. And they said that it usually happens in May. It gets windy in May. Give or take, obviously. And it's true. Right now, you can hardly see the horizon. Yes? Very cloudy, isn't it? A lot of dust in the air, correct? But the dust is going to settle, isn't it? So when you say dust is a colloid, when you say smoke is a colloid, be careful. Dust with a specific size particle, smoke with a specific size particle, but don't wave your hands and say smoke is a colloid. Smoke and air, right? Dust You know, Enzo, you're very specific. You said, well, dust is a colloid. Well, it can be. But if the dust particles, here's some dust. There's a dust. Is that going to fall out? Big piece of dust, isn't it? Dust. It's not a colloid, is it? Yes, I'm being silly, Dylan. Dylan's looking at me like, that doesn't sound right. Okay. Thank you for noticing. So, but the point is, you got to make sure that it fits some of the physical parameters before you say absolutely all dust in air. Because I know I have a, what do you call it, a balcony, and I put my clothes sometimes out on the balcony, and I get home and I shake them. Sand goes all over the place. Hey, the sand got up there, right? Did it stay? Was it stable? Was it really a colloid? No, it's more of a suspension, wasn't it? Because the dust is going to fall out, isn't it? Tonight when you go home, how many people have a balcony in your apartment? Raise your hand. Okay. Has it ever been cleaned? Ever? It's been cleaned. Okay, so it's probably pretty clean. Okay, I want you to eat off it tonight. Sarah got a kick out of that. Yeah, she almost snotted all over herself. Yeah, I know exactly the building she lives in. And very dusty there. Sometimes you can actually hear the dust in that particular building down by the Persian Gulf, the sand hitting the window, can't you? Yeah, it's really windy down there. So go home tonight and eat off your balcony. Where'd that sand come from? Where'd that dust come from?
In the deserts.
From the... Thank you, Mustafa. Mustafa of Arabia, I like that. Excellent, it came from the desert. I thought it came from New Jersey, but I was wrong. Okay. I brought it with me? Okay. You talking about me? Huh? Okay. So, what else about whipped cream? Definitely. So, you have to look at, is it stable? Is it stable? What's an emulsifier? What's an emulsifier? How do you spell that, emulsifier? Can you give me a spelling on that?
EM.
EM, excellent. Sounds like you're making this up as you go along. The Australian is trying to do it from memory. He goes around, he does walkabouts, and he talks and uses the word emulsifier all the time in a sentence. It's very exciting to be with. Okay.
EMU.
Emulsifier, L S I. Emulsify, is that spelled correctly?
You said emulsifier.
Well, I did say emulsifier, but we're getting there. This is a journey, remember? It's a journey. It's kind of like being a teenager. It's like a bad journey, but, right? So emulsifier, how do you spell it? Look it up in the dictionary.
S-I-F-I.
Emuls, what?
I.
S-I?
I.
You're sure? You looked those up? Weird word. How many people have ever used those words in a sentence in your entire life? Raise your hand. No one is raising their hand. You've never said, all right, everybody, let's practice so you can say. Emulsify.
Emulsify.
Emulsion.
Emulsion.
Emulsifying.
Emulsify.
Emulsifier.
Emulsifier.
I am an emulsion.
I am an emulsion.
Good. I hope not, but that's fine. You use the word a lot.
So we have soap.
What? Oh, he said the four-letter S word. Oh no, not that word. Yeah, it was a four-letter word to Vikings, right? Soap. Okay. What is soap?
Soap is an emulsifier.
Soap. Soap is an emulsifier. Yes.
Yes.
And what does an emulsifier do?
It's emulsifier.
It emulsifies. So let's say you have oil and water. And can you mix oil and water?
With the emulsifier.
With an emulsifier. All right, let's look at a really tiny half, a 1.5 nanometers, just a drop of oil, like it's going to be, that drop of oil is going to be greater than 1 nanometer, but less than 1 micrometer. Okay? Is that okay? Can you see that dot? Can you see that dot? Okay? All right. Let's take that dot and we're going to blow it up. Okay? We're going to enlarge it. We're going to get out the microscope. Okay? Okay? A little weird I can do that, I know. My students used to say, they looked that up and they said, Mr. Darcy, that's really bad that you can do that because it means that you're crazy. And then somebody found a website said that if you can draw a nice circle, it means you're crazy. So I don't know if that's true, but I don't know. So anyway, so that's a giant oil droplet, and we've got to somehow keep it in solution. Well, let me show you how to do this. Has anybody ever heard of carbon? Thank God, it's May, it's a chemistry class, you've all heard of carbon. I feel better, okay? Excellent. Okay, so if I take carbon, how many bonds does carbon form? 4, yeah, excellent. So here's carbon. Let me make a chain of carbons. Okay, I'm going to make a small chain, is that okay?
Okay.
Is that all right? The chain can be large, but I'm going to make a small chain. Yes? But just ignore me, it's actually many carbons, okay? I'm just trying to make a point. All right? Okay. So, I have these bonds. Right? Now, at each bond, I'm going to have a hydrogen. Okay? Now, pretend this bond is long. Everything all right?
Some of it's cut off.
Some of it's cut off. No, it's on there. It's just, you have to, thank you. Matt, my videographer, was very concerned about my video here. Yeah, it's there. Okay. I'm there. I'm good. Okay. So this can be very long. Okay. I just don't have enough room. Is that okay? You get that?
Yes.
You okay with that? Okay.
Yes.
So you see this C, double bond O, bond H. This is called a carboxyl group. Carboxyl. 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 Okay? Carboxyl group. In organic chemistry, we call it a functional group. Yes? Have you heard of acetic acid?
Yeah.
Acetic acid is an acid because of that group. Somebody right now, look up the molecular structure of acetic acid right now. Who can do that? You three hoodlums in the back. Look up the structure of carbolic acid. No, acetic acid. Okay? All right, so now if I take off this H, what do I have? Do I have a charge? I have a negative charge, don't I? So do you see that that's an ion? Now, this is so long that this end doesn't know what this end is doing. This is the organic, nonpolar, oil-like. Yes? Dispersion forces, dipole-dipole. So this is going to be the organic. Dispersion forces. Dipole, wait a second, just hold that thought. Thank you. Dipole forces. Those sort of intermolecular forces. When you think of the weaker intellectual, when you think of the weaker intermolecular forces, That's that side. Okay? It's oil-like. Right? It's oil-like. You okay with that? Yes? Okay. Now, all right, so, so when you say like dissolves like, organic, oil-like, non-polar,
Why you cannot wash things that are oily with water?
that's right.
Use soapy water.
That's right. Non-polar, dipole-dipole, dispersion forces, organic, oil-like. That's that side of the molecule. Yes? It's so long that this side doesn't know what this side is doing. Mustafa,
Aren't the eggs in mayonnaise an emulsifier?
I can't hear you.
Are not the eggs in mayonnaise an emulsifier?
Maybe. We're going to talk about that. I want you know what? Look that up. Look up eggs, mayonnaise, and emulsifier. Okay, we're going to look at it. Okay? So, this is ionic. Salt-like. Ionic. Ionic. Salt-like. Okay? It's going to be, there's going to be hydrogen bonding here. Someone look up the 4 intermolecular forces really quick, and we're going to have a quick review. Somebody look it up online. Do it. Do it right now. Hydrogen bonding. I'm going to have hydrogen bonding here. I'm going to have it here too, as well as another bond, yeah? Okay? So, this is hydrophilic. What does that mean, hydrophilic? What does that mean? Hydrophilic. Likes water. Water likes water. What's hydrophobic or hygrophobic?
Scared you of water.
Scared. It's afraid of water, exactly. It doesn't like it.
Like hydrophobic sand, the cold sand they sell at very high prices. That you can drop in sand with water and then take out and I'm still gonna be dry. They make hydrophobic claims, it's really cool.
Yeah. Yes, do you get it? Okay. So what happens is you take these long chains. We're going to draw them like this. Here's the center. Okay. We're going to draw them like, we're just going to draw like 8. We're not going to make a zillion of them, okay? So you're going to go like this. 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 See what I'm doing? Not yet? Okay. There I have 8 of them. Okay? I'll make them green. Okay? There I have 8 of them.
I like your song.
A little flower here, huh? You like that flower? It's a flower. Okay? I'm going to erase some things here, okay? Is that all right? I'm going to erase this. So, these are called long-chain fatty acids. You've heard of glycerides and things of that nature? Yes? Yes. So what they look like is actually like this. These are carbons. Carbon, 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 carbon. Carboxyl group. Okay? Carboxyl group. Yes? So what happens is, this is the organic end, right? So you get this, let's do it in black. You get this fatty acid in here.
Fatty what?
Fatty acid. Fat acid. Fatty acid. Okay? Fatty acid. Okay?
I thought you were referring to this.
No, I wasn't calling anybody fat or an acid. My girlfriend's old name was Fatty Acid. Okay? So there it is. Okay? Now these are my hydrophilic ends. This is my hydrophilic end. Okay? That's my hydrophilic end. So in other words, it looks like this. Right? This is going to be this. That's this. This is going to be the charge. Right? So, now remember, this is a blow-up of a little drop of oil that's less than a micron, okay, in length, in width, right? This is in water. This is water. So you have these giant water molecules all around it. It's flooded with water molecules. Right? So what's going to happen? What's going to happen? Here, I'm going to get this hydrogen bonding, aren't I? Aren't I? You see, what keeps a particle of a colloid, what keeps it in solution? What keeps it stable? Electric charge. Electric charge keeps it stable. Correct? What's a very simple word for this thing here? What are these things? They're molecules. And what do the collection of those molecules make?
Soap.
Soap. I didn't say it until just now. Soap, yeah. I made soap. So soap is going to be, here's going to be oil, grime, dirt,
Disgusting things.
you know, gross stuff. Can you see that green? Can you see that? Does that come up?
Yeah.
That green? It's clear? I can't see anything without my glasses here. Not bad. Okay. So dirt. Okay, organic stuff. And what does this end attach to? Water. So soap can be an emulsifier. It can be an emulsifying agent used to stabilize the emulsion, creating a colloid. You get it? Did I use the word emulsion too many times? I may not be able to use the word emulsion until June now. I think I've used up my emulsion credit.
I've been emulsified.
What is it?
I've been emulsified.
You've been emulsified. And you better be careful. You may be emulsified. Exactly. So that's an emulsion. Okay? What I'm going to do now is I'm going to show you a PowerPoint that I'm going to narrate and put up on the tube as a lecture. And that's going to be on colloid. It'll be on everything. It'll be on chapter 15 on aqueous systems and water. But I'm also going to do a lot of work on colloids. Because colloidal chemistry is actually pretty amazing. It's technical stuff. A lot of things that you see in life are actually colloids. You don't really see a lot of solutions. You know, you trip over a colloid before you're going to trip over a solution. Yeah? So let's look at that. Let's see if I can set that up, and I'll see if I can film it. I'll see if it takes. Colloid, this is Colloid Part II. This was long, huh? It was long.